Hello everyone, welcome to the channel and welcome to this playlist in which we are discussing about different instructions of 8085 microprocessor. पिछले वीडियो में हम लोगों ने देखा था कि Alexa इंस्ट्रक्शन जो है वो किस तरीके से काम करती है and today we are going to learn about MVI and particularly we are going to learn about MVI R,D8. I will discuss about the applications of this instruction and how you can use it. So let's begin. So सबसे पहले MVI stands for move immediate. So if you want to move your data immediately to a register, we will use MVI. MVI R,D8 as you can see here. This R stands for register and this D8 stands for 8-bit data. For example, I want to store 32 in my accumulator. My init accumulator is also a register. So what will I write? I will write MVI A, 32H. Similarly, if I want to store 32 in B register, what I will write? I will write MVI B, 32. Similarly, you can store different data values in different registers that are available. Register A stands for accumulator, then register B, register C, D, E, H and L. You can store data in either of these registers. It is a 2-byte instruction. That means it requires 2 machine cycles. First machine cycle will always be opcode fetch, as we have discussed earlier as well, that any instruction that you want to draw timing diagram for, the first machine cycle will always be opcode fetch and second will be memory read. So opcode fetch has total 40 states, memory read has 3 states, so there will be total 70 states. In opcode fetch, we have different opcode, which is unique identification of particular instruction. We have different opcodes for different registers for the same instruction. For example, if you want to print something in accumulator with the help of MVI, then the opcode will be 3E. So that is unique identification of the instruction MVI A. Write something in register B using MVI, you are going to use opcode 06. For C we have 0E, for D we have 16, for E we have 1E, for H we have 26 and for L we have 2E. Now that I have told you about the opcodes of different instruction, let's see one of the examples for timing diagram and one of the instruction. Let's draw a timing diagram of one of the instructions. So this is the instruction I'm going to draw a timing diagram of. Instruction is MVI E, ABH, where AB is my data and E is the register. So I want to write AB in register E. So first, what is going to happen? First cycle will be opcode fetch. So you can see here we are having opcode fetch machine cycle. Here you have clock. On 80 to 87 we will have lower order address. What is our address here? So address is 2000H. So what is the lower order address here? Lower order address will be 00. So 00 is here. The higher order address is 20, as you can see here. So higher order address is 20. A8 to A15 address lines. Then we have the opcode. The opcode for instruction MVI E was 1E. Let's check again. MVI E. See, opcode is 1E. So we are going to have an opcode in A0 to 80 to 87 bus, as you can see here. Now remember, for opcode fetch, S1 and S0 signals will always be 1. Read signal will go down when opcode is getting fetched or opcode is getting executed. So see, during the time when opcode is getting executed, the read signal is down. After that, memory read cycle. Again, we are using memory read cycle because I want to read AB from the data I have read from memory and I want to paste this AB or I want to put this AB in register E. So to do that, we will require memory read machine cycle. We will not require memory write machine cycle because we are not writing something into the memory, we are writing it from the memory. So we'll only require memory read cycle. We just need to read, we don't need to write because we are writing in register. Whenever you are writing in register, you don't need memory write cycle, you just need memory read. Okay, so you will read this AB here in opcode read machine cycle, and similarly this time the address will be the next after 2000. So address is 2001. So the lower order address will be 01, this address. Higher order address will be 20, which will be this. I0 will remain 0 because again this is a memory operation. S1 will become 1 and S0 will become 0 for memory read. Similarly, read bar will remain same as opcode fetch, and write bar will also remain same as opcode fetch. Now let's try to let's try to learn it by executing it in sim8085. So what I'm going to do, I want to write MVI A comma 32H. That means I want to store 32 in address bar. Sorry, I want to store 32 in accumulator. So here I'm running it. Alright, see, program counter is showing memory address 800. So what I'm going to do, I'm going to write 0800 here. See, 3E and 32. So what is this 32? So this is my data. What is this 3E? So 3E is opcode for MVI A, 32. See, here's 3E. Instead of this 1E, in our instruction we will have 3E, and instead of this AB in our instruction, what we will have? We will have 32. And this 32 will be stored in accumulator when I run this. Right now the value of accumulator is 0. So I'm running it. Now you can see that the value stored in accumulator is 32. So this was MVI instruction for registers only. In next video we will learn about using MVI instruction with memory location as well. So we will keep this video till here. Thank you very much for watching. If you have any doubts, queries, questions, mention them in the comment section below. I will be seeing you next time with next video. Thank you very much for watching. Goodbye for now.